Hi, in this video we will do more examples for substitution, and the focus will be on the cases that the integrand is a function to the power -1 times the derivative of that function. Well, this is the case that the power of the function is -1, or you may see this as we have a fraction quotient. The numerator is the derivative of the denominator. These cases, the substitution, the good substitution is you put gx, the denominator, as u, and du is going to be g prime x dx. And if you apply the substitution, you're basically going to have 1 over u du. Numerator times dx is du. And well, this will give us ln of u plus c. Okay, let's see these in examples. You see right away here, look, the denominator is x cubed minus 5x squared plus x minus 3. The derivative is in the numerator, so that means that we are going to have the case we just mentioned, x cubed minus 5x squared plus 5 plus x minus 3. du is going to be 3x squared minus 10x plus 1 dx. And well, this will turn, you see, this whole thing is du, and we have 1 over u. So this is ln of absolute value of u plus c, and while plugging back, you get ln of x cubed minus 5x squared plus 5 plus x minus 3 plus c. This one, okay, so you have a fraction. This is one of the signs of the substitution we are just using, that you have a quotient as an integrand, and the denominator, the derivative of denominator is in the numerator. So then in that case, you set u to be the denominator, du is going to be numerator, du is going to be numerator times dx. And again, we are going to have 1 over u du, which is ln of absolute value of u plus c. And in this case, it's ln of absolute value of e to the power x plus 1 plus c. That, well, in this case, e to the x plus 1 is always positive, so you don't need even to put the absolute value there. Integral of tan x, well, you say, where is a numerator and denominator? This is interesting, that you can write tan as sine x over cosine x. And you see that the derivative of the denominator is minus sine x. Okay, so I can put minus there and a minus outside. So now the derivative of the denominator is in the numerator. This way, if you set u to be the denominator, du is going to be the numerator, dx. And again, you have negative 1 over u du, which is equal to minus ln of absolute value of cosine, well, absolute value of u plus c, and that is minus ln of absolute value of cosine x plus c. Well, you can work a little bit more. You can take this one in. So ln of, you see that this will go to the power, absolute value of cosine x to the power -1 plus c, but that is same thing as secant x plus c. So this is one of the items that you can add to your table of integration, that integral of tan x is equal to ln of absolute value of secant plus c. Well, this was another case that happens a lot, so better to do more examples and learn how this substitution works.